Hi again, everybody. In this screencast, I wanted to do some example problems with Gay-Lussac's law, just to make sure that we all understood how to solve problems where either the pressure is changing or the temperature is changing. Okay? So here is Gay-Lussac's law, and the purpose of 6.5 was for you to sort of derive it from data. But here's what Gay-Lussac's law says. It says that the pressure exerted by a gas at a constant volume is directly proportional to the Kelvin temperature. Okay? So that means that as our temperature of a gas increases, as long as its volume is staying the same, the pressure goes up a proportional amount. Right? And this is another way of saying that. It's saying that if you take a gas at a certain pressure and you divide it by its Kelvin temperature at that pressure, you're going to get a constant K. This is not referring to the Kelvin unit right here, it's just referring to a constant. And this is what you're supposed to see in 6.5. And then if you do the same thing here, if you then heat that gas up and it's at a new pressure and a new temperature, and you find the quotient of that pressure and that temperature in Kelvin, you'll get the same constant. Which means that for any gas at a constant volume, the initial pressure over the initial temperature equals the new pressure over the new temperature. And this is the actual equation for Gay-Lussac's law, okay? And this is it phrased another way. Instead of using 1 and 2, this I stands for initial. So this is initial, and this is final. Okay. So the initial pressure of a gas divided by its initial temperature in Kelvin is equal to its final pressure divided by its final temperature in Kelvin. And this lets us do calculations. So let's look at an example problem. An aerosol can has a pressure of 1.4 atmospheres at 25 degrees Celsius. What pressure would it attain at 1200 degrees Celsius, assuming the volume remained constant? Okay, so I'm going to do this problem below. So we have an initial pressure of 1.4 atmospheres at 25 degrees Celsius. So our initial pressure is 1.4 atmospheres at initial temperature of 25 degrees Celsius. And then we are asked, what pressure would it attain at 1200 degrees Celsius, assuming volume stays the same? Okay, so we're increasing the temperature to 1200 degrees Celsius, and we don't know the final pressure. Okay, that's our unknown. Now, our equation tells us that P1 over T1 equals P2 over T2. That's Gay-Lussac's law. But our temperature has to be in Kelvin. Must be in Kelvin. If it's not in Kelvin, we'll get the wrong answer. Okay? Because the Celsius temperature is not directly proportional to the pressure because Celsius has negatives. So we have to convert from Celsius to Kelvin. So our temperature in Kelvin equals the Celsius temperature plus 273. So if we convert that first temperature to Kelvin, so that would be 25 plus 273 equals 298 Kelvin. So this is T1. And if we add 273 to T2, we'll get 1473. And now we can plug in and solve. So we're solving for P2. So I'm actually going to start by multiplying both sides of my equation times T2. That way I'm just solving for P2 in variable form. Okay, so P2 is equal to, P1 times T2. These cancel over T1. And now I can plug in my variables on the left here. So P2 equals, let's see, I have a pressure of 1.4 atmospheres times T2, which is a temperature of 298, T2 is 1473 Kelvin, over T1, which we calculated is 298 Kelvin. Kelvin is going to cancel here. My units are going to come out in atmospheres. And then I just put this in my calculator. So I have 1.4 times 1473 divided by 298. To 2 sig figs, I get a pressure of 6.9. And this should make sense. It looks like that our temperature has gone up by about a factor of 5. So that means that our pressure should go up by about a factor of 5 as well. That's what directly proportional means. Right? And our units here are atmospheres. Don't forget the units. Right? Atmospheres did not cancel, so our units are atmospheres. And that should match the work here. That's exactly what it is there. I'll do one more example problem. A sample of a gas has a pressure of X. If the temperature changes by 350 over 250, what will be the new pressure? Okay, so let's make a new page here so I can do this problem. All right, a sample of a gas has a pressure of X. So the initial pressure is X. The temperature changes by 350 over 250. Okay, so this is what the temperature changes by. And then what will be our new pressure? P2 equals question mark. Okay. So we also don't know T1 here. I'm just going to keep T1 as T1. And we just know that our temperature goes up by a factor of 350 over 250. Okay. So what does that mean? It means that if we take our initial temperature and we multiply it by 350 over 250, that gives us our final temperature, right? And we're asked what will happen to the pressure? What will happen to the pressure? So let's look at our equation here. Our equation tells us that P1 over T1 equals P2 over T2. Okay. So we know if we look at our equation up here, we can see that the ratio of the second temperature to the first temperature is 350 to 250. So if I rearrange this equation here and I cross multiply so that I end up with T2 over T1 equals P2 over P1, I can see that my T2 over T1 I know is 350 over 250. So this is the ratio of my final temperature to my initial temperature. And this is the ratio of my final pressure to my initial pressure, right? This is the ratio of my final pressure to my initial pressure. So returning to the problem up here, what will be the new pressure? Well, the new pressure is going to be exactly this much higher, 350 over 250. That's what this tells us. It tells us that the ratio of my final pressure to my initial pressure goes up the same amount that my temperature goes up. So the answer for this one should be 350 over 250 times whatever that initial pressure was, in this case X, okay? Which should make sense. My temperature is going up by this factor, so my pressure should go up by that factor as well. And you can simplify that fraction if you want, but the ratio won't change. See, there's one more in this PowerPoint. I'll let you try this one on your own. And then I'd like you to try to see if you can complete 6.6, which is in step 2 of the 6.5, 6.6 page on Schoology. Please see some of the other YouTube videos if you get stuck on any of these